All right, hello and welcome to Ether Cosmology Roundtable number 76. Tonight we're going to be going over Flat Earth and the Celestial Sphere, specifically addressing about 8 different points that have been made by Jeran from Jeranism regarding Flat Earth and the inability to explain some of this celestial phenomenon. So we're going to be going over some of the things that that we can explain with without making too many logical leaps, and then we'll get into the more speculation cosmological aspect of things. And since this is a cosmological discussion, the open panel is highly encouraged in this episode. So we'll be referencing back to everyone and hoping to get more input. So if anyone would like to contribute to the conversation, you're welcome to join on our Discord server. A link will be put out in the chat here in a second. We'll keep an eye out for verification as we go through. But everyone that's here and hearing this now, as we go through these, if you have anything that you want to contribute or add to it, you are more than welcome. With that said, Shane, take it away, good sir.
Thanks, Alan.
Oh, wait, sorry, real quick. Before you take it away, we're joined also here by Kyle Adams from Glowbusters and Glowbusters Tech. What's up, Kyle?
Happy to be here. Thank you for inviting me.
Excellent. Yeah, I think because we wanted to address some of Jeran's claims. I think that I saw you were putting out videos directly addressing Jeran's claims, so I wanted to invite you specifically to our roundtable to be a part of the discussion as a community. So
I'm really trying to address what he's actually saying, but I'm not trying to beat him over the head or anything, or submit to Flat Earth or anything like that.
No, I think we're all capable of attacking the argument. Like if I say that your argument is retarded, it doesn't mean that I'm saying you're personally a retard, right? I'm just saying that maybe you took a stance that you want to rethink, Especially with we can attack the argument, but I think I'll just list some of the things that he listed. That's the reasons why Earth's a globe now, and then we'll go through them one by one to see what we can come up with. So he's got the South Celestial Pole, right? That's the star, the southern pole convergence in the sky. He's got the South Pole exists. That's the South Geographic Pole, so requiring a longitudinal convergence. Upside down and backwards moving sun and moon in the south, right? The Tropic of Capricorn direction. I don't know what he means by that one. Does anyone know what he means? Does that have to do with the sun azimuth in the south? Or because he says the tropic changes direction?
He's talking about viewing. It's talking about your apparent view of the sun when you are south of the arc of it, how it will ant-arc.
Yeah, that's what I thought he meant. Yeah, okay.
Yeah.
All right, that's what I thought it meant, but reading it now, he specifically says the tropic direction, and that's confusing to me, but we'll address that. The southern stars, so I guess that's different than the South Celestial Pole. Southern star trails, I think those are one and the same. We'll address them, I think. Circumpolar stars in the south, those would be the stars that circle around the supposed South Pole, the convergence point, which is latitude dependent in the south. Sunset and sunrise times and angles, definitely will address that. And the second apparent sun needed. Well, that'll probably be towards the end. Good to see we got Joe Handy in the crowd. I'm sure maybe we can attribute some help from him when we get to that explanation. But to start us off, let's hit sunrise and sunset times and angles. That's the one I have for a video up right now. Let's see, it should be 3 or 4 minutes. We do need volume, so I think I'm in Discord. Let me make sure. Can you guys hear this?
Let's talk a little bit about the sun angles.
Yep, you're solid.
All good. All right, so we'll watch this real quick and then we'll reconvene.
Or more accurately, the sun's. So let's talk a little bit about the sun angles, or more accurately, the sun's arc. Right, the path the sun appears to take.
Oh, yep, you're right.
In the sky over any observer. If we start at the equator, it's the only time you'll see this equidistant line indicating complete symmetry, right? So there's the sun.
I say symmetry, but I mean this line. It's the only time that it's an actual line, right? That doesn't ray north or south in any way. It's right on the line. It's the equatorial star trails.
Over here, it's rising to this observer due east, right? And it's rising, it's going to its zenith, and it's approaching, and it's going to set. Now, of course, the real sun is all the way over here, going around its circuit where the GP carries it between the tropics, and where it's observed for this observer, is who's exactly on the equator, is the only time you'll get this perfectly symmetrical line, right in the middle. Anywhere else in the world you observe the sun from will have an angled arc, right? If we go a little bit north, say about 45, and we look at the same thing, we see the sun now does this crescent, right? If we look at it from the south, it would do this. It does this crescent shape. Here it is. Again, this is the sun, this is the moon, sun rising and setting. And now it's no longer making a perfect symmetrical line. It's making this arc. This is the path of the sun that you would expect on flat Earth. The flat Earth model expects the sun to be moving in inclined arcs because that's how it's observed all the time. In fact, from that observation, they have coupled together the globe model, right? Based on flat Earth elevation angles or a flat plane and an observed celestial body making an arc as it rises and sets. And also more decreasing arcs as it makes its journey from tropic to tropic. And put that all together, it would appear at the north and at the south, and this is how you get the globe model. You get the inclination of the sun's arc manufactured to create this theoretical ball, without which you would just move this celestial arc back and forth as you moved in latitude, right? This is a good representation of what we're talking about. In January, it's making this low arc, right? In March, it's this higher arc, and in June, it's this super high mark, right? In midsummer, almost. This is where this person is, right? And you can see it's almost at its zenith. That's the only thing that creates the southward crescent for the rising and setting of the sun south of the equator. It's the inverse that you would see in the north, right? If you took this and moved it around and just inverted it, that's what you would see. This is what you would see as a northern observer looking south towards the sun's path. And again, another representation is it's making its celestial arc, and its arc is season dependent. Again, this is where they created the 23.4 degree tilt of the whole world, because they were assuming first parallel light rays, and also that this was symmetrical. So therefore, the whole world must be tilted at this axis, right? It's all contrived based on this simple observation. The sun doing this arc, as we saw before, the sun doing an arc. You look at it from inside, it would be doing this, right? Rising and setting, just like this. So when we take it to explain a southern observation of a southward facing sunset, it makes perfect sense. We move our observer, say south of the equator, we're in South America. We have it rising and setting south of east, right? So if we look at our bearings and our compass, this crescent, which again is matching the crescent we just looked at, the only way it can work is it's rising south of east, so south of this eastward line, right? And it's setting south of west. So as it goes across, its zenith is up top again, and now it's curving back down to set. And again, it looks like this as it sets into the apparent opposing direction. That's what the sun would look like. That's what we would expect on a flat earth with a limit of vision, right? The mechanism that causes this cutoff of all you can see is the physical limit of your vision, right? If you don't see forever, then you would have a limit to your vision, and same amount in all directions, then it would create this hemispherical dome above you. That's just the natural geometry that we're talking about here. It would create this. If you have a limit of vision, this is how it would look.
Right. So that's pretty much my answer for sun arc, right? And it's, again, based on everything that we observe. If we were to just continue it from the northern known observation, right? If it's a 24-hour sun in the north under the North Pole, and you move to, say, 45 degree latitude, then it would be, whoops, sort of over here. Then you would see the sun start to crest like this, and the more towards the equator you would go, the more this would straighten out, right? This is about at 45 degrees. The more towards the equator you would go, the straighter this line would get, until you get what is observed at the beginning, the equatorial, right? The actual linear progress of the sun from due east to due west at equinox, right? That's at the equator. And then if you go further south, you get the inverse of what we were looking at before. Instead of seeing this, it would go the other way, right? And that's just a facet of having a hemispherical limit of view. That's what creates this southward sort of facing. Now, again, this is just for an apparent position. This is where we would see it personally because of the limit of your vision. So what do you guys think about Jeran's first globe proof?
Well, I think we covered it really extensively the other day with optics, right? This is an apparent object that we're seeing at our limit of vision. And we see in what's referenced as a sky dome, right? So if it's a latitude dependent, how we see the sun in our sky dome, to use the technical terminology from a manual on solar panels from the 60s, then what we see exactly is no different than what the quote unquote globe would predict, right? This is just a function of how we see optically.
Right. So I was just trying to explain from in the north, right? If you just want to look at where you would see the sun, this is what you would see from the northern observer, right? So complete circle in the north, you can see the sun going around you, moving a little bit towards the equator. It does this anti-arc, right, towards the source, go right to the equator. It does completely linear, right, due east and due west, and then go further south.
Yeah, and I want to add something right now that looks a little confusing, right? Because there's two suns here, right? We got the sun going around the tropics in a circle, but we see an arc or antarc in the sky depending on our latitude. And the sun that we're seeing circle in the tropics, right, is representative of the GP of the sun, right? That's where if you were between the tropics at noon, that's when you were to look up directly, you would see the sun at your zenith, right? Apparent sun, like it's always apparent, even the zenith, right? Still, but that's where that position would be. Now, where you see it in relation to that is what we're looking at inside of your azimuthal grid there, like inside that local dome. It's not to be confused with two separate suns or anything like that.
There's one actual sun and one apparent sun, and that's really important to remember. There's a number of different things that are really important to remember when it specifically concerning this model, which was made by Walter Bislin, if I'm not mistaken, and that is that first of all, this is assuming exact locations in the sky, and so this is just kind of a working model, making a lot of big assumptions, and that's just kind of one of them. Another thing here is I think it's just talking about kind of assumed arches of that refraction, showing that the light would have to bend in this way in order for it to be seen, right? And so that's a really big thing right there too. So it's not exactly taking any kind of atmosphere or taking any kind of firmament into account here. It's just saying that the light would have to bend this way if the sun's actual position was right here and we were to see that apparent location right over here. Follow?
Yep.
Yeah, that's just to plot out the trajectory or whatever, like in reference to where its true position is. Yeah.
Right.
It's just for the reference. Yeah.
Yeah. So what our models strive to do is create a backwards engineered thing, right? And that's the entire goal. And so we say, okay, this is what we observe, and now we're trying to build a model based off of what we observe. And so we understand that we all see an apparent position of the sun. Now we're trying to figure out how our model makes that happen. And so that's kind of what makes this whole Walter Bislin thing really invaluable, is saying, okay, this is the apparent position of the sun. And though the Walter Bislin model shows the sun, the actual location of the sun being in one place, in reality, that it doesn't have to be in just that place. It's just one hypothesis. There's a million other hypotheses out there where we could put the exact location of the sun at any number of different locations, and it would end up being similar. Like you could change the height of the actual location of the sun. And does that make sense?
Yeah, I think that model is it's good for displaying the apparent position, but you'll notice that actually it employs the same method as stellarium with an azimuthal grid over the observer. And if you think about it, when they use stellarium, this is also what the globe is doing. It's putting a local azimuthal grid over the observer to model celestial locations and azimuths and directions, right? So funny enough, I think Jeran's other favorite tool that he uses all the time, this thing, let's see if I can switch this quick enough, change stream.
I'm gonna say that's what I really like about this model, is because it does a really good job of illustrating the concept of a personal dome of vision.
Well, so does this, right? This is the exact same principle and the same model. Yeah. It's only just got a globe underneath it now. And so if Jeran likes this format better for using the same alt as grid of the local observer with the same hemispherical limit of vision over the observer to which to model these, to model stellar observations, then to each his own, I guess, right? And this is exactly the same as this. So when
you say globe, right? Yeah, you're talking projection, right? Yeah, like it's the projection is defined by the coordinate system that it's using, which is the latitude and longitude. So if both of those are using the same thing, they're both equally valid and representing the exact same thing. One can't work, and while the other one does, because they're the same. So if one doesn't work, then they both don't work.
Correct. Now we can actually, let me go into my map projector real quick while we're at it, because that is technically speaking an orthographic globe projection. That's what this spherical model is, right? Compared to say a Mercator projection or an azimuthal equidistant projection, they're all projections of the same coordinate system. This one happens to just be called the orthographic globe. Here, I'll prove it. Let's go back in my program real quick. All right, change this. My favorite program is called G Projector. I use it all the time. It is straight from NASA. Start with an equirectangular. I'm going to bring it in just so we can show what we're talking about. And also, we're going to use this for the next question, I think. So there it is, equirectangular. So here's our orthographic globe, which is equal, right? This is called the projection. See, it's the projection. Oh, wait, I'm not showing anything.
Yeah.
You see the equirectangular projection software?
Let's do...
So is that what you wanted to show?
I think for this one, I got to use my whole screen.
Yep.
So let's do this. And then, good? Yeah. So here's my graticule, right? Not the word that Shane made up to get out of answering map questions. It's literally the technical term for what it's called when you're in this coordinate system, right? When using a projection. And then here's the type of projection this is, the orthographic globe, right? This is an actual projection of the coordinate system. It's not the basis or the start or any different from any of these other representations of the same coordinate system. So what we have with our sun modeling program is a preference of which coordinate system you like under your personal azimuthal grid, right? If I do this, and I focus a little bit, we have an actual same projection. This is just azimuthal equidistant, right? This is the type of projection for our same graticule, and we can easily hop right back to our orthographic and go back to the globe. So like when we're looking at sun modeling, which one appears underneath your specific model is a complete matter of personal preference, right? Makes no difference.
So what you're saying is that a projection is literally just your choice. Doesn't have any physical meaning in reality. It's just a projection.
Yeah, and the favorite projection, right, is what's in contention. So one of these projections, the Earth has to physically have Earth curvature to substantiate how it works. So and we could test that, right? Like we could make measurements, as they say, right? We have various different methods of doing that, and primarily, celestial theodolite being number one, but we can touch on that at the end. But finding out what is the correct interpretation of this coordinate system is what we're doing, right? The coordinate system itself isn't inherently globe or inherently flat, right? It's literally a map of the stars based on their position during the vernal equinox.
Yeah, it's just a mathematical model.
Right. So, I mean, we were talking about sunrise and sunset direction. So I think we handled that one. And then his other point was sunset and sunrise times. So, I mean, I think he said you can't measure any flat Earth sunrise times, but we should differentiate that an observation of the sun is inherently model independent, right? The direction with which you see a sunrise and the elevation at which the sun appears are not globe dependent or flat Earth dependent. They are the observations from which you can build models, right? And I understand that this observation is the backbone of the globe model, but I don't understand people saying that this is globe data, right? So if I have an azimuth and an elevation for the sun, that's just the direction with which it appears, right? An azimuth is just direction in degrees of 360 with true north at 0. And then it has the elevation angle at which it appears. So the separation angle from which it appears above the horizon measured in degrees. That's what that is. With just those two pieces of data, you can't tell me that's globe data. That's what this is built on, the direction and the elevation with which you see the sun. So as far as sunrise and sunset times, this accurately shows for every observer anywhere on Earth, for any time, any day, right? It's just the accurate timestamp, the sun azimuth, direction with which it's expected to rise, and elevation, right, for the time. That is literally what this is built on. That's all it's showing. So to say that we don't have it and we can't model it is silly to me. That's a silly proof. And again, if we just want to flip it back to our orthographic globe projection under the same model, or use this model if we want, then it's, no different. It makes no difference. They're both have the same predictive power. All right.
Post-dictive, really.
Real quick question. So basically, the azimuth is the direction in which whatever celestial body you're facing, right? So if I'm facing true north, and then the ASI will come out like 256 or whatever, and that would be to the right. Or in that case, right, from true north, and then the elevation angle would basically be the angle at which you view the celestial body as it goes overhead, or just depending on what time it is and where you are observer-wise, right?
Yeah, so over here, again, so this is my observer. Pretend I'm this cross over here, right? And this is looking true north.
Yep.
So my azimuth will be 0, 1, 2, 3, 4, 5, 3, all the way around 360 to get over here. And when we have the sunrise,
no, left. Okay.
Yeah, it goes this way clockwise all the time. So when I say it rises it tells me sun azimuth 105. That's 105 degrees from true north.
From true north.
And that's how
all
it's
right, going
right?
clockwise.
Yep. So 90 would be due east, right? Before that is more south.
180 is behind you. Yes. 256 would be to the left, or whatever. Yeah.
So that's how you do azimuth.
Back left.
That's what we're showing. So when we say we don't have azimuth and elevation, no, it's right here. It happens to be for October, 18th, but we can do now or whatever.
So Jeran's biggest argument against all this is what could be causing the light to bend in such extreme ways. When you've got the sun way over there on the other side and it has to do this wild warping in order to line up in just this right area to make that apparent sun. That's his big argument.
Well, I mean, I understand that's what people say. However, what this is an empirical model, so it's showing observational data. And as Alan correctly corrected earlier, it's post-diction, right? It's not even a prediction. It's based on cycle data. You're not really predicting the sun will rise. You know it based on the direction and the inclination of the season. You can make a valid prediction based on that data, right? So it's not really dynamically explaining the light, right? That's not what the model is showing. It's showing you where you would observe the light. That's an empirical model. Mm-hmm. As far as dynamically, it's not showing you what keeps the sun floating around the flat disk. That would be a dynamic cause. The original model that Bislin had his dynamics, if you will, in the bottom. He is not in the model at all. It's all the way over here, right? He has his dynamics way down here. He just wrote them in. He said, "Look, this is all because of gravity and constants and Kepler. It has in the code has nothing to do with it. The dynamics are not present at all."
Wait. The dynamics aren't even in the codes, bro. They're just in the comments.
Yeah. Yeah, he says,
"Yikes, brother, that's insane."
Like this is because of gravity and this Epuria. He references the ephemeris. Yeah, but it's just code translating geodesic to personal azimuth grid.
Classic. Well, if anyone here has a dynamic cause that they would like to propose for the ability to see the sun relative to the elevation and time of year and latitude, this is your moment.
Yeah, I'm not gonna fall into that trap.
I don't know what causes the sun to move in the sky. It's beyond, there's so many things about the sun, moon, stars that I just don't understand, and I don't believe we have the ability to really understand at this time. But when it comes to understanding what causes the light to bend through the sky, that's a different story. And I feel like we've got a lot of a lot of research that has really gone into understanding the atmosphere and how the atmosphere is able to bend the light that passes through it. That's been phenomenal. I believe, what was it? Decimal Z. He did a model where he just took the atmosphere alone and just put that into AutoCAD and was able to get a lot of refraction simulated. That was really great when it came to explaining sunsets.
Yeah, but so here's the thing, right? This is like the speculative part where we can get into, because here the way that it's been proposed to us from globular mechanics, right, is just simply that the Earth is curved. Yeah, we've been unable to substantiate any Earth curvature. We've in fact, falsified it multiple times through various methods. So even though, obviously it's easy to just be like, who knows, right? It's not our job to really know. We could never know. But if anyone has some speculation that they want to throw in, like, this would be the time to do it, because the Earth curvature is literally Earth curvature is actual speculation. But people just think that it's more real because they're standing on the Earth and they're like, well, it's just so big or whatever. So they feel like their claim is more real than somebody speculating about how they think it could work. And it's like, Earth curvature is a cosmological belief at this point.
You take the Earth curvature out of there, and now you got to explain, how does the light do that without the Earth curvature? Because they got to face the same problem here. Because we just don't observe the Earth curvature, and so
either the sky is curved or something about it is curved, causing it, or that would be an easy logical deduction. If we can't find any curve on the ground, then it's probably somewhere else.
All right. So I think that summarily takes care of sunrise, sunset, angles, directions, and sun to sunrise times. So next, let's hit he's got the South Celestial Pole and Southern Stars. I can't for the life of me think why that should be two things. Can anyone?
They sounded like the same, and I didn't want to be the guy to ask and be like, are those not the same? So
all right, let's go through the basics real quick.
Saying they're the same, I'm okay with it.
Like, I addressed them together, and I don't understand if I don't.
When listening to Jeran's whole spill on all of this, he didn't really keep it together very well. Like, I've got 8 points, and then he starts talking about them in random order. Like, he's explaining point one, and then he suddenly starts jumping into a completely different point and mixing it in with point one, and then it was kind of all over the place.
Let's read from what he typed on the Telegram. So we have the South Pole exists, and then what was the other ones? Or no?
Southern Star Trail. So yeah, they look to be two. I don't know if I ruined the order, but it says the South Celestial Pole. Many have speculated that this spot in the southern sky sweeps across the dome, but I saw it in Punta Arenas. It is stationary, like the North, and does not move, meaning it's impossible for Australia, Africa, and South America to all see the Southern Celestial Pole in their south. So he says, I guess I heard him say he thought that it moved. And I don't know anyone who thought that the South Celestial Pole moves. I do think that it is a latitude-dependent sort of optical convergence that can be seen at the same elevation for everyone, depending on your latitude in the south. Right. So from the second that it becomes visible south of the equator, it's visible at the same latitude all around that latitude ring, just like all things in the sky and celestial phenomenon. Right. It's all latitude dependent. I don't understand. He says sweeps across the dome.
Yes, that's the big thing right there. Sweeping across the thing. So in his video, he made this big deal about the southern stars and how they should sweep all the way across the horizon. They shouldn't be just in one location doing a big circle, even though in previous videos he showed that, he totally understood that you've got a southern circle, right? And so, it's kind of the best way to describe it is you get this big sweeping movement going from left to right, and there is no southern star circle. That was his big point in his video. The big argument that we're trying to fight here is he's like, I saw the southern star circle and they exist. And he's acting like this is a new thing when previously he fully acknowledged it. So he's kind of going back on what he used to understand.
Right. Well, I got a pretty good, 8-minute explanation of all things South Celestial Pole that I put together that we can watch. I think
let's go
present it pretty well from my perspective, and then we can attack the rest of it. If you guys are ready.
The basics real quick, so Shane can explain how the stars work. Right. So this is you. This is how you perceive the sky, hemisphere around you. Nothing groundbreaking here. Everyone agrees on both models, as far as I can tell. On the globe Earth, this is exactly the same. It's the basis for the creation of the globe model in the first place. Not a physical dome running around with you, not going to touch other domes, right? The movement that you see happening, you would think is because of curvature and no other reason. Even though every day you see other tall buildings, mountains, people, street lamps, everything in the world recede into the horizon proportionate with distance as a facet of perspective. We're just saying the stars are doing the exact same thing. The globe position, if you didn't know, is that actually the stars are doing the same thing, but for a totally, completely different reason than everything else in the known universe, and that's called curvature. We have a completely solid, math-based, logically cohesive alternative. Our radius, of course, being a facet of the limits of perspective. Absolutely sound, mathed out. Makes total sense. You can derive the radius right back from the optics of the human eye. You can also play with proportionalities on the radius criterion to do the same. So a completely solid, logically cohesive, math-based alternative application of what you've been told is the radius of Earth is the radius of the limit of your vision. So how do you see celestial objects? Well, like this. They appear in the hemisphere around you and then appear to move, either of their own accord, 15 degrees per hour, or with you as you go across the axis here. Right? Moves 1 degree in the direction of movement as you move 69.07 statute miles in proportion with your direction of movement. That's all we're saying. And here's just an orthographic view of stellarium showing you the same thing, except my star isn't moving. This is just a 15 degree per hour rotation sped up over a person with a celestial sphere of globe proportions around the observer on a flat plane. Now let's just do a quick walkthrough about how the stars and the celestial poles work on flat Earth. So to start, let's just assume that you see in globular dimensions, meaning you see in a hemisphere around you on a flat plane up to the dimensions prescribed by the globe. So in a sphere or half sphere of radius 3959. If you were to take a circumference of the circle of the limit of view, would be about 24,901 statute miles in a circle. Apply this to the celestial heavens and we get a latitude-dependent pole around which things appear to rotate in the north. Circumpolar stars in the north. Here we have a 45-degree tilt. Someone is in northern latitude looking at the stars. This is what they see. Polaris, right about at an angle, not directly at the zenith, not directly at the equator. So going to the equator, you start to see both celestial poles pop up. Now, this is because the optical convergence known as the south pole starts to pop up. If you look back over here, only right about here is when you get far enough away from the center with your hemispherical limit of view to, first of all, lose the original only center of rotation. There is only one rotation of stars. Interferometry, every measurement ever taken of motion, has only registered one source center of motion. All the interferometers have to be aligned to this source of rotation or motion. They cannot be aligned to any other. It is only one, singular. So when you get far enough away from this singular source of rotation, your limit of vision, judging by the example of corpuscular and anti-corpuscular rays, which would appear to bend what is flat light or parallel light above you, it would appear to bend that parallel light into a dome around you, and that your vision does the same thing just to the nighttime sky. It only makes sense that you'd experience the same thing at night as you do during the day. So during the day, if your vision is bending these parallel sun rays above you and they're arcing them into convergence points behind you that they're not really doing, your perspective is doing that, then that's all that we're saying is happening at night. Your perspective is taking these long star trails that are emanating from a singular source and spreading outward, and it's warping it into a counter convergence point produced by optics only when you get to the equator, only when you get far enough away from this rotation, okay? And when you go further south of the equator, you get the optical convergence point known as the South Pole popping up because it's latitude dependent. And that would be the point around things which appear to rotate going forward. Right? Now to take it out, to make it a little bit bigger, back it up. Again, if you're under the North Pole at the zenith, this is what it would look like. Everything spinning around you like a perfect hemispherical dome. Oh, it should be said, this is not to scale, and my model of the dome is much bigger just to show that scale, but for all intents and purposes, it represents the globular dimension. So it represents a dome of radius 3959. It's not in scale in proportion to the map around it. We'll go over that later, but just so everyone knows. Notice the similarity to a globe. Right? If you're standing right underneath it, this is what you'd appear to see, everything rotating around you. Now, if you move your observer just a little bit, say, halfway between North Pole and the equator, about 45 degrees, you get the apparent rotation convergence point appear to rotate. It moves about here. Go back to the equator from this side, and we get to see the same thing. Equatorial star trails, where both poles appear to be visible, but neither one really is. They just be equatorial. Both appear to be polarized. Now, you go a little bit southward, you're far enough away again from the central rotation. You're far enough away from this where you can no longer see it. That's why it appears to dip below your horizon. 6,218 miles is the distance to which you can see that above the horizon. When you pass that distance, you can no longer see it. It's appear to set. It's over here. And now you have the counter convergence point known as the South Pole, the optic convergence, appearing to pop up and is now latitude dependent inversely, and is now the point around which stars appear to rotate in the south. Again, latitude dependent. So it's maintaining the same degree of latitude, the same elevation depending on your latitude in the south. The same relationship that Polaris has with elevation angle, that is to say synonymous with, the south optical pole convergence remains the same relationship in the south. So Again, maintaining directionality here, of course, has to be maintained in a circle around the central cylindrical axis for this map. That's why the compass is moving forever. It always is maintaining the relationship to the center. We're going to overlay our Stellarium orthographic view to see the exact same thing with a little bit more graphics. Okay? Stellarium uses the exact same model and the exact same method to portray the stars. In fact, it uses a stitched together grouping of azimuthal or alt-az horizon-based coordinates that they then modeled to create the celestial sphere. Flat plane angles stitched together to create a bigger sphere that, when unraveled, would mimic a point-for-point correlation of the celestial sphere to geographic long latitude. That's all it is, guys. And the reason I can overlay the orthographic view of Stellarium onto the flat Earth dome model is because they are doing the same exact transform. They are taking a personal alt-az coordinate system and transforming it to a celestial equator-based right ascension declination. So the celestial sphere effectively is just a conglomeration of alt-az observations of the sky from all over Earth that they stitch together into a ball contingent upon the correlative relationship of longitude and latitude to right ascension declination. So because for every star there's a ground position and a time, because of that one-for-one correlation, they have mapped these two spheres one for one to each other. But this is just taking a geodesic or geographic coordinate system or the celestial sphere and converting it to your local alt-az grid. That is all that is happening here. So when people try to misunderstand or misuse, it's just ignorance. Ignorant, same code process. Not the exact same code, it's written in different languages, but the same process of coordinate transform and translation, making this run. That's all it is. Like geodesic to alt-az, boom. And then as you travel, the same translation, although applied differently, right? Latitude dependency. That's all.
All right. I forgot about that one. I think that one has.
That's a great video, but your choice of background music is disgusting.
So I took it out with my new cool AI tool, but then it botched it, and every time I spoke, you could hear it a little bit, and it was weird. So I decided to leave it in. I definitely was like, well, I'm not going to re-record all of it, but I don't want this background. But yep. Let's see if this one has a background. I think I cut this one out. Or maybe not.
If we recall the first.
Yes. No background. So this is just a follow. It's like a 3-minute video for the mechanism and the effect, because we had some observed phenomenon, we had some rotation and counter rotation, and people contrived different dynamic causes for this, right? So I'm going to attribute it just to perspective. That's just what I think it is. Like, well, I'll explain it to you.
The principle was the rotation and counter rotation explained by perspective and relative motion, right? We had one actual center of rotation. We had apparent motion of that rotation changing depending on where and which direction you looked, where you were on the Earth and which direction you were looking in. The motion never changed, but your perspective induced the motion to appear to move counter, right? Everyone remembers that. Just going back to P-Brain's video about rotation and counter rotation, and perspective being the root cause. I find it helpful to go through each phenomenon and its effect, and then to make sure we know what is causing each effect, so that we don't inadvertently loop other causes to other effects. So we have the counterclockwise rotation in the north appearing to rotate clockwise in the south as its counter. Once you move in the south and look to the south, you see the counter rotation. The toilet paper tube rotating in one direction but appearing to rotate in either depending on which side you look is the best example of this uniform motion that we can ever use. Perspective alone will show you this rotation moving both ways if you look in one direction or in the other. That's the simplest way to put it, and it's the best explanation for the counter rotation that we see in the south. We have the corpuscular rays of the sun converging behind you on the opposing horizon to show you that you see in a sphere that your vision will wrap light around you in this fashion. So that means that your perspective over the great distance will put things that aren't converging in a convergence point, like the end of the rays of the sun.
Love it.
They're not actually converging around only you. They're going out in perpetuity in both models, right? But in your model, perspective puts those rays around you, even though apparently to you they're parallel. So just a quick thought on motion and perspective. We only have one source of motion, but our perspective makes it look like more. If we have motion like this, and you're in the north, they see that the stars are rotating one way. Everything goes together synchronously. If you go south, however, and look from the opposing viewpoint, if you turn around and look the other way, then the same motion converts, right? It looks the opposite. It looks to rotate the other way. See how that works? So in the same rotation, same motion, depending on where you're looking from, will make it move one way or the other. Simple explanation. I do want to make sure we keep the observed effect and the mechanism separate. For each effect, we'll keep the mechanism. If it's more than one, we'll write it, but we'll have a specified mechanism for each observed effect that we deal with. So second one would be convergence and counterconvergence. If you're looking from the opposing horizon, when the light beams appear to converge on it, we'll call that the convergence point. And then when they extend past your head over behind you and converge on the opposing horizon, that's the counterconvergence point, right? The place where they're not really converging there, but if you didn't know that, you would expect to see a sun right where the beams converge. The mechanism that we had for that is the optical limit of your visual space and sufficient distance. So if you understand that what you see is just the curved visual limit. If you have an understanding that you can see 59 miles into the sky in any direction, creating a little sphere of your celestial horizon that moves with you wherever you are, governing the limit of your visual space. And you'll notice that at the edges of the space that you can see, your vision will put it into a sphere, meaning that what you see will appear to converge. Now, again, personal dome, nice as a geographical coordinate transform in Stellarium to let you know that the Walter Bison's model is valid, because Stellarium uses that very view. That's where I got that footage.
Right. So that's the South Celestial Pole answer. I think for me, optics-based convergence based on your spherical limit of view, forcing things that are in fact parallel to appear to converge. That's the explanation for the whole sky. So it gives you your spherical limit of view. It's how it lends itself to the globe model. It's how you get southward azimuths for celestial sunrise. What do you guys think?
I really enjoyed the part with the tube and seeing the different rotations on both sides. They're both going in the same direction, but it's just a matter of which direction you're looking in. That it appears to go clockwise or counterclockwise. That was actually Jeran's point 3. That he just seems to have utterly forgot or something. I don't know.
Yeah, this one was pretty easy, and this particular demonstration was like the most basic example of exactly what we were talking about that I could think of, right? It's a paper towel roll right underneath your nose, right? And it's going in one direction, one constant motion. If you look left to your eyeball, you'll see it going counterclockwise. If you glance to your right with your right eyeball, you'll see it going clockwise. Obviously, it's not changing, right? But you're looking in different directions, one uniform motion. Yeah, that's what's happening with this guy.
Yeah, that illustrates it super, super well.
He also had Southern Stars, but his write-up is the Southern Star Trails have been one F you can't answer and still cannot. Are all stars rotating above us as a disk, or does the evidence say it can't work that way? I mean, I don't think the stars are rotating above us on a disk. I'll tell you that. That does not work, right? That is not what's happening. I don't think there is an orthographic third-party position of the actual stars that we can point to. Same thing with the sun, right? How the sun has to be personal for each observer is exactly what I think happens to everything in the sky.
Are they on a disc or are they on more of a dome shape? We don't know. That stuff is just beyond our ability to understand, as I said before. But the main thing is that it can be modeled. We can have assumed positions, and you can warp that in many different ways. Just play origami with it, and we can still end up making it work with this kind of wireframe mechanic.
Let me see. Change stream. I think I can do this. Bring up Canva real quick. I have some other stuff for stars and how we perceive them, because I don't think that I agree with the orthographic position that the model puts it in, right? I don't think there's an actual disk rotating flat above us. I do think they are all at flat Earth elevation angles, as proven with the celestial theodolite, right? The new revelation is for any star that you can see, no matter how distant, its actual elevation angle to the Earth is the same where you are, exactly where you are. There's no tangent way off down the line. The elevation angle to any observed star is going to be the same throughout for as long as you can see it. Crazy. Let's see if I do this.
When you start playing with distance, the distance of stars, the biggest factor that's going to come into play is going to be the luminosity of the star. And so that's where different organizations will end up saying, oh, well, that star is actually humongous. It's way bigger than the sun. And it just kind of gets really ridiculous after a while, because they just assume, oh, yeah, that you should be able to see that light from infinite amounts of distance, as Bob Nodell would say. He would continue to say, they just expect you to be able to see forever, when you really can't, because of the inverse square law of light, which causes light to dim over distance, because the light from the sun, moon, and stars, none of it is parallel. It all ends up scattering and becoming more scattered over distance, which causes it to become dimmer and dimmer.
Yeah, I'm not concerned with their standard candle distance luminosity test to try and make all the flagrant dark matter work with the ridiculous redshift that is definitely not electromagnetic retardation, but acts exactly the same or whatever. There's no need to unpack all that nonsense. Where's I going? Canva. Where's my presentation mode? Hold on. I got star maps. You guys can see that?
Yep.
All right. But I can't control it. Presenter mode. There we go. All right, so if you're going to look at, like, say, where the stars are, right, this looks like a jumble, but what it is a Mercator representation of all the stars, right? This is the same thing. If you look at a path, this is, say, the sun's path, or it could be the tropics, or it could be the zodiac, right? This is what you would look like if you were
Never seen a Mercator projection of the stars like this. That's interesting.
You haven't? Okay, maybe this is super interesting then. Hold on. My stream can't see this. There we go. So if we were to project it, as we would playing with our G projector, of course, right, we get this.
Image of it.
And if
It's just showing a black screen right now.
Oh.
You did it right. I can see it.
You can.
You might have to leave and come back.
There we go.
Close and yeah,
I might put it in super HD mode as well. Let me bring that down a little bit, maybe. Yeah, 1080 30 should be fine. Okay. So this is the same star map, but projected on an AE, right? Just an azimuthal equidistant version of what we were just looking at. Again, same thing, except it has continents. So what I always say, what I'm trying to relate is the celestial to the geographic, right? If this map here with the land masses is the geographic graticule flattened out, because that's what it is, and then we have the celestial sphere flattened out, overlaid over it, what this helps parallel is the relationship of lat long and right ascension declination, right? Latitude, longitude is just the degree of separation on the globe, measured eastward and westward versus north and south on the globe. But a right ascension declination is an inclination above the horizon in a time in which you can expect to see it. The time conversion.
This is the model which planispheres use.
Yep, could be. Definitely.
I've seen the star charts.
Yep. This is more the whole map. I think planispheres are limited by latitude, if I'm not mistaken. And then this is the whole.
Yeah, they don't really do a good job when it comes to the southern stars, but they focus more on the northern stars. Although you do have like 2 different planispheres that end up focusing on 2 different areas. But even in the southern stars, it doesn't exactly do a great job of showing the southern star rotation, as I recall. But I could be wrong on that.
Yeah, it's a very equatorial star map. But what I'm trying to compare is latitude and longitude to right ascension declination. So right ascension declination is an elevation and a time. Why would you need a time, right, for a star? Well, if these are rotating around the Earth, then the GP position rotates around this latitude line. It's always at this line. The only thing that changes is at what time it'll appear there, right? 24 hours on the clock, 24 hours around here, which is why when you convert right ascension declination to longitude, latitude, you have to do an hour angle transform, right? Which is 15 degrees per hour. You got to work that back in, and that's how you get your degree translation of your right ascension declination. So that's how latitude and longitude is synonymous with this star right ascension and declination. They're the same thing, which is why I always say the celestial sphere is just the geographic graticule, right? A lot of people don't get that. But if we were to look at, say, the same star map and we were to project it back in our orthographic globe projection that we're so fond of, right? It would look like this. Here's the actual land masses. Here's the stars outlined out. If you know a time and a star, I can tell you where you are on the graticule, right? Super synonymous relationship. Here it is back to back, orthographic, and then the continents. This one I put together just because the zodiac is here. It's why you can see the zodiac is so important. It's because they're visible from everywhere all over the Earth. If you can see half of the hemisphere, right, then anywhere you can be on the Earth, you can almost see almost all the zodiac. But yeah, that's what I wanted to go into real quick about stars, right ascension, declination, latitude, longitude, because we were answering southern stars and how we don't have an answer for stars as a flat disk. So I think we answered that. What do you guys think?
Hey, Shane, this is Joe. You send me the link to those star maps on the AE projection?
Sure, yeah.
Yeah, I appreciate it.
I definitely have a video that's I think it's the genesis of curvature is what I called it, but I wrote a quick Python script that would convert anyone's position based on an observed star elevation, and you would just tell it what time it was and what the elevation was, and it would tell you where you were on the graticule, and it would output like a Mercator, a globe, and an AE projection. It would give you coordinates for where you are based on what star you were looking at, just to prove the point how inextricably linked it is.
We've been looking at a snapshot of the position of the stars the whole time. The land is just additive, right?
Well, like I've been saying, it's called cosmography. They didn't unlink them before. The land was linked with the stars because the ancients knew what was up, and they knew they couldn't do one without the other. They knew they needed the sky to look at the ground. So I mean, they inextricably linked them. Only recently do we delink them, right? Split them apart and call something cosmography, and then keep it separate from cartography, and then no one can figure anything out. And people think longitude and latitude links to the Earth, right? The whole argument about meaning that it's a coordinate system based on the stars is that it's only based on the stars. The spherical shape is a 1-for-1 because it's based on the celestial sphere, as I just pointed out, right? The geographic graticule, also known as the globe, is literally just another sphere made to mirror that sphere point for point. That's how they came up with ground positions for stars, right? Once you have a ground position for every star, you know what time it'll be there. You can create the map, which ends up being the globe. And then you use astrogeodetic surveying via GPS and satellites to iron out the difficulties, blame it on geopotential gravitational issues, et cetera, et cetera, et cetera.
Yeah, imagine if we had the freedom to correct our star positions to make our map to say that there is a gravitational anomaly such that it's causing our plug bob to not be truly going down to the ground, and it's deviated, so we have to tilt our device.
Imagine if anytime it wasn't right, we could just make up dark bullshit, and then that would fill the gap until I could come up with another explanation later or whatever.
There's dark matter that's not interacting with the light spectrum around us, so we can't see it. We can only detect it through the deviation in our plumb bob with respect to the stars. It's like, okay, anyone buying that? Anyone want a piece of that? Nope. Okay. Well, that's how we substantiate Earth curvature, through another thing that no one's ever had to account for other than, using it as the explanation to reify the first thing.
Like there's three major steps when it comes to substantiating our model. One is looking at the geography of the Earth, or geology, really, just kind of looking for that, what we can observe when it comes to the Earth. We don't see any curvature. Okay, that's the most observable thing for us. And then we build on that. Okay, well, what's above the Earth? Okay, well, now we're going to start looking at the atmosphere and how the light passes through the atmosphere. That much we can study that to death. And we have done that like over and over and over again. And that's something we really continually do. And then after that, we get above that, and then we start observing the firmament. And we've got many observations concerning that as well. And so it's just kind of one step upon the other, and trying to figure out exactly how the light travels through that. And that's, the higher we get, the harder it is to understand. That's just how it goes. And so there are quite a bit of things concerning the firmament that we're just going to have to assume things with. And so, yeah, we can give them a hard time about dark matter and trying to do that. But when it comes to that kind of stuff, it's kind of a placeholder. And so we can throw however many placeholders we want to in the firmament, because all we have to go off of concerning a lot of things up there are assumption based. It's hard to verify stuff way up there, if you follow.
Yeah.
Oh, and I think that,
All right.
yeah, real quick, I just want to address something else I think that Jeran was talking about. It's converging meridians. I saw his stream. He was trying to measure converging meridians, and he was just going to Google Earth and like drawing a line and trying to measure it and saying that proves the globe. Listen, man, that one was painful, because what he was doing was obviously a method that some glober told him was absolutely how you do it on flat Earth. And spoiler, it's retarded. It's a retarded method, right? It doesn't show anything. What he was doing, right, is he would go on Google Earth to any point. Am I sharing this? Can you guys see it? Yeah, you good?
Yep.
You would go to any point, and he would say, okay, at this point over here, what's the distance between longitude lines? He would say, okay, the distance between here and the North Pole is whatever, 8,000 miles. And then he would use 2 pi r. And he would say, okay, then the radius based on this radius, then the circumference of this circle is X, or whatever that comes out to, right? And he would get some astronomical figure way out here, because the longer, obviously, the bigger the radius, the bigger the circumference, the bigger the longitude difference. That is not how longitudinal convergence works. Again, this is a flattened out celestial sphere, right? This isn't the flat Earth map. Australia isn't this size. This isn't equidistant out here. This is not what it looks like, right? Actually, this will answer 2 at once, because he was doing convergent meridians, and he was talking about the geographic South Pole. Right? Where is the geographic South Pole on flat Earth? Well, on flat Earth, I mean, who knows? On this projection, it's exactly 90 degrees. Where is 90 degrees? This outer circle. If I wanted to center it on 85 degrees, I would have a South Pole. Like this different projection. You see how that works? If I just do this, you end up getting a concave's version of a map, right? It's the same equidistant projection, except it's not focused on the North Pole. The coordinate system doesn't really have a 90, right? If you look at it like this. But the actual point for 90 would just be over here. That's what it means. It's only representative on a sphere, right? There's only a South Pole on a sphere. There's only a North Pole on a sphere. This South Pole only exists within this coordinate system. It only exists in this model that is spherical based on the stars. It doesn't actually exist on the Earth. What Jeran was saying was that, based on the South Celestial Pole, based on the fact that I can see that, if I just walk towards that, everyone will converge there. And Jeran, if that was true, we would all be on your side. Like, no one's ever done that. I don't know how you got to the conclusion that because you saw the South Pole, then there is a South Geographic Pole underneath it that would be converging if everyone just walked toward it. I don't know how that follows, right? That doesn't seem that seems crazy to me. Obviously, if that were true, then North-South circumpolar navigation were true. We would be a lot less flat earthers. But so that answers the geographic South Pole as a concept, right? Only exists in this model in this coordinate system, and specifically when you center it like this. It is this outer ring, but that doesn't mean that's where it is in reality, right? It also doesn't mean that Australia is this size in reality. It doesn't mean that all the countries get bigger the more south you go, right? That's also not what it means. If we were to look at, what an actual map would be like, it wouldn't be this stretched out. It would have, well, we'd probably use the hexial, triaxial, boraxial projection, I think. Let me see if I have that somewhere.
Oh, yeah, the old hexial, biaxial, boraxian.
One of my favorites.
Yeah, you actually touched on like a 3-piece here, because this actually goes into plane routes, because there was a recent... You can tell the shape of the Earth by a plane flying over it and the route they take, in reference to the maps and great circles, even though we all know a great circle can intersect it's not defined by a sphere. You can do that with the same projection, right? Same tool with a AE map that's just a circle. It's not specific to a sphere. And then on top of that, the coordinate system is symmetrical. So as you went over earlier, because it's flattened out, like it looks asymmetrical, it looks more flat, stretched out than it is, and that is the idea that these flight routes don't work, and and all this stuff is completely misrepresented, because again, they'll be drawing straight lines on a Gleason as well to make the case. Like that's the biggest part of it too, right? Earlier you mentioned the misuse of the tool, and it's like, where is it appropriate to draw a straight line on a Gleason's, and where is it not appropriate? Can we go over that real quick? And then you're already touching on the circumpolar orbits and terrestrial navigation, which also ties into the plane routes and satellite routes. As we went over, none of these things show the true representation of a circumpolar route using the coordinate system that is invariant under transformation, given the proper corrections from your boy Hixius Boraxius III, or the tricycloton cubic matrix, or whatever it's called.
I forget. I think it's called the Hexian triaxial projection or something, because it's got this.
No. It's the correction matrix. It's something with a T. It's like Triscus, or I don't know. Anyway, I'll look at it later. But when you apply the proper correction, right, you'll get the corresponding route in how it should look. And when we do that for all the publicly available satellite and terrestrial navigation that is said to be circumpolar, none of it shows the correct transformation where it would actually represent something going over a ball and coming around the other side. So yeah, you already touched on, you kind of went over all of those in the same thing. So
Yep, I forgot that all those were problems, right? Because we talk about them all the time. It's like my favorite subject is maps and coordinate systems, and how it does improve the shape of the terrestrial Earth. But
it will real quick shout out to Ruhif and Ether Cosmology, who went over the flight route situation. What was that, like 8 months ago?
Yep, we had a debate and we lost horrendously. I think is how that he whooped us. Yeah, no, we just showed how those flight routes, when plotted as geodesics, actually, the argument from our position is an argument of proximity, where the pit stops make more sense with the continents outlaid. It wasn't distances. It wasn't because people don't know how to measure distances on the Gleason's map. Distance isn't determined by the visual scale with which you draw the line. It's determined from the distance between the points of longitude and latitude, right? As a projection and as a projected coordinate system, the data is preserved via transformation and under transformation because of the underlying coordinate system. It's not preserved because of the distance that the line appears to be when you draw it on the map. If you draw a straight line, it's wrong, because you're not maintaining a direction. If you mean to draw east and west, it has to be a circle. You can draw a straight line on this map. For instance, this line right here from the North Pole to the equator is actually 6,210 miles long, based on 69 miles per degree, right? But it also is the same representation as the quarter of a sphere as a geodesic curve, because an aspect of this map is that it corrects great circles, or it straightens out great meridians. How could it be that this distance from the North Pole to the equator is the straight, as it is a flat line, the same distance as it would be for a sphere of 3959? Because that quadrant from the North Pole to the equator would, if this was a sphere, it would be this point to this point, and that is a geodesic curve, and that 6,218 miles is the same distance represented on this map. An aspect of this projection is that it straightens out great circles. So when people draw a circle and they go, look, haha, how come it has to be a circle? And it's like, well, if you drew a straight line on a Mercator and then you projected it to the AE, it would have translated it to a circle. So I think that's a common misconception. The other thing is, if you were to represent the Earth, I think we were talking about, I think this would be my preferred representation, right? It is still a projection from the North Pole, which we can still alter and change, but it does give the continents the proper sizes and the proper dimensions. So it maintains dimensionality, I would think, right? So proportionality, rationality, these grid lines are still getting bigger, but of course it's the same size. So this is another representation of it. If we were to do the circumpolar navigation, right? This is a satellite orbit that's said to cross it. No, it doesn't. We have all these in here. Yeah, so we hit geographic South Pole, South Celestial Pole, Southern Star Trails, flight maps, flight paths, geodesic, linear versus straight. What else we got? What are we missing? Do we miss one, or do we hit them all?
Well, people are upside down on the globe. I don't know. I think that was pretty much it. We covered all the sky stuff and a couple extra ones.
Oh, upside down. Yeah, I think Kyle has that one. I think he's got a good video, but I think he could probably explain it. That one's a pretty easy one, but I think Kyle does a pretty good job.
Oh, nice, Kyle. We got a video you want to share real quick, or something you want to go over for that one?
Sorry, which video?
Your I think so. The one you addressed Jeran directly on the upside down. You put like a piece of paper on your ceiling, and then you walk to the other side, and you were like, "Look, it's upside down."
Moon.
Yeah, that's perfect.
Yeah.
Oh, that's the classic.
Right, so I don't understand how someone can go from seeing that, understanding it, and then being like, "Oh, it's a phenomenon, completely unexplained, dude. I don't know how it happens."
Oh yeah, it's not even a real argument. All right. Well, if that's the case, then I think we've addressed everything that we could. If anyone has any input or anything that they would like to add, now would be a great time. We have many different subjects to cover. Why you think there's a celestial south pole, why you think how you think the light distribution works, etc.
Well, let's see. The thing that I don't know how to address, that I don't have an answer for, to be totally honest with everyone, is southern circumpolar stars, right? Stars that appear to rotate around the south celestial pole in the south, but then to try and draw an orthographic position of where you think that is, it gets tricky, of course. But that's why my position is that there is no third-party orthographic position that's the same for everyone. There's just the apparent position, as we say. Let's see. Actually, let's go here. I put on stars. So circumpolar stars, I just want to point them out, are these stars. If I go to the south, these stars right here, and again, these aren't real stars in the model, but they would be a set of stars that rotate around the South Pole. So they go just like this. They never set. They're always visible. And of course, the kicker being they're visible for everyone at this latitude around the outer edge of the world. Right. That's the one. That's why I was pointing out the star maps, right? I don't think that that's their true orthographic position. I don't. Whoop, hold on.
The biggest thing for me to try to remember is that the stars aren't what we are told, or at least not what NASA claims they're told. NASA's claiming that they are giant burning balls of gas billions of miles away, and that's their big claim. And the more we realize that, no, they're totally wrong about that. That gas doesn't clump in a vacuum, and then explode and turn into a star. When we start to get rid of that and reevaluate what the stars could be, then it ends up putting more things on the table that to take into consideration.
Yeah, definitely. I mean, because again, they pretend to have an answer for everything, literally everything in the universe. A dynamic cause for why you see that redshift is because the galaxy is shifting away slightly in that direction because it's a burning ball of hydrogen, helium, and iron that accreted over a long period of time, billions of years ago, which via mass attracting mass and gravity formed a disk, and then a ball within attracted other balls, which caused a system, which then produced a giant black hole, which is around which everything in the world rotates. Like, okay, all right, guy, that's a crazy story. I don't think I should have to replace all that or whatever.
Bro, we're dealing with people who've accepted a dynamic cause of nothing. Right. Everything came from nothing is an actual proposed mechanism for cosmology to explain the positions of everything in the sky with respect to how we use them to navigate terrestrially. One of the ways we got here, guys, from nothing. So just keep that
I think one of the interesting things
in mind
to look into here is just the constantly changing color of the stars. Like when we get a zoomed in picture of a star, it's continually shifting colors. And the whole redshift theory and the whole spectrometer thing, it all depends on stars being a solid one color or spectrum of colors. That's kind of the whole thing. We get 3 different beams of light coming from that one star, and it ends up showing up on a spectroscope, but it doesn't quite explain the continually shifting colors. Does that make sense?
Yeah, they actually had to redefine how they interpret the measurements to explain that by making different assumptions and just using math to express a way that it would work out if XYZ conditions were present. That's why they have specific chemical compound structures for how they interpret like the elements of the stars, because it's like necessary for them to explain their hypothetical backwards engineered way to explain the shift that they see, because no one's ever seen what they see when they look at the stars and do spectroscopy. No one ever has seen that in the lab, right? Like you can do spectroscopy in a lab and you can measure different gases and the effects and all that through spectroscopy, but the way that they relate it to the sky is completely based on a ton of assumptions, as you were laying out earlier, to make it fit so that they can tell the story about how they ended up with a big old burning ball of gas that came from nothing, mind you.
Yeah.
Imagine at the beginning of the Bible, it was like, who wrote this? And it just said no one. Like that.
No one ate here.
Dude, that's the backbone of their starting point. Where did it all start? From nothing.
I've run it all through the debate forums, and everyone's like, oh, well, those stars are just out of focus. I'm like, yeah, being out of focus isn't going to cause it to change color. Like, over and over again.
Dude, speaking of out of focus, we had Taylor go in the field, and she went to an observatory and had a professional astronomer focus in a star. And you know how we've been told that pulsating fluffy ball of light that's oscillating, right? We're told that we're doing it wrong. That's out of focus stars. That's what they look like in focus, bro. That's what the dude told her. He brought it into focus, showed the same thing that we've all seen on YouTube videos with the P900 and all that. He showed the exact same thing. She's got video of it, like 3 or 4 of them.
I want to see that video. That sounds amazing.
I'll send it to
gold
you
right there.
On the Skype. Yeah, dude, it's nuts.
Oh, I forgot the last thing. The last point that he made was you need an apparent son. Second apparent son needed.
Well, we kind of already covered that
I was gonna say,
at the
wish I knew
beginning.
people who knew who had ideas about what that meant.
Oh, that was the thing I wanted to bring up.
It was basically to explain the 24-hour sun, how you could see it in Antarctica and while it's on the other side of the Earth, and you would have to say that there's 2 apparent suns, but where our position is, we only ever see the apparent sun, and relative to the latitude and time of year, the elevation of the sun is, you're going to be able to see it at your latitude. So
apparent sun is the key word there. Okay, and so when we all have our own individual points of view, that means there are as many apparent suns as there are people.
Oh, how
there
dare
are
you!
as many apparent suns as there are people, and so
Well,
my favorite example of this is called sun glitter. If you go out onto a beach and you see the reflection of the sun in the water, and how it has that big long trail in the water going right to you, okay, you as a person individually see that sun trail in the water. It's called sun glitter, okay, and you see it come directly to you. But someone else on the beach, they don't see it going directly to you. They see it going directly to them. You don't see their apparent sun in the water. And it works vice versa. And so every person on the beach, they all see that apparent sun in the water going directly to them, but they never see each other's.
Yeah, and on that note, we're going to end on an apparent sun simulation from FE Core from how long? I'm not sure how many years ago this was now, but yeah, this is something that was kind of put forward, years ago in terms of how we perceive the sun individually, local to us. So yeah, Shane's going to play us out here. Then we're going to wrap up for the week. We'll be doing Globe Busters this Sunday. The subject matter will be ether physics. We're going to be covering that. And then next week on Globe Busters, we'll be doing a follow-up. We'll be redoing this for that. So stay tuned.
Nice. I think Kyle was just describing this video because this video was hugely influential
Right.
when I saw it. And I think this is what gives everyone the explanation. I'll just talk us through it real quick. As the source projection is the sun produces a light ray that to an observer standing on the surface of a pond, the light ray appears to go from the sun to your feet directly. That is your personal light ray. You see that. If you have a friend next to you, he would not see that sunlight go to your foot. He would see a separate light ray go to his foot, which you cannot see, right, from your perspective. So if it's a perspective-induced personal ray, then the sun would be a personal source projection. That's the argument put forth here. What they do to model it is they take an observation of every altitude for, let's see here, I'll play it right here. Yeah, every sun azimuth at every latitude for a year, and they run it through a supercomputer, and they get this data model at the end for what a personal sun would be. Based on actual data, here's how they would model it.
Observer on Earth. We did this by taking just one longitude.
It's kind of hard to see the reflection of the water there. But yeah, that comes down to the point is just that observation right there tells you that there are as many apparent suns as there are people.
Yeah, I think this is what I was thinking of.
And inputted the data from observations for azimuth and declination of the sun and traced the sun object for that location for a year for each 10th latitude north and south of the equator, and just let the data run its course for a year.
Right there is what it would look like, right? That's exactly who.
But the model became so heavy with data and tiny hair-thin tracer lines that even with a super machine,
we're not seeing it. We're not. I don't know. It should be good.
I'm seeing like a weird hula hoop going in circles.
I mean, is Kyle behind everyone?
Yep.
Okay. I was like, wait a second. I'm looking at this.
we couldn't render the result.
Looking at the inside of a computer?
After some trial and error, we finally managed to get a clear view on the end result. And even with our sun being an equal distance to the observer, the shape and layout ended up in a torus field around the Earth. We still have to figure out how to do proper 3D vectoring to get all the observed speeds and changes in the motion of the sun, creating a more true shape. But it became very clear to us that based on Ken Wheeler's research into magnetic holography, that the sun we see is projected into the electromagnetic field in the sky. The objective sun follows the magnetic field lines that are unique for each location on Earth. So the real sun is a source coming from outside of the so-called firmament, which probably uses light polarization that is projected into the magnetic field and rendered through the atmosphere. It is no coincidence that all sun arcs combined create this torus-like field, and this is version 1.0. As soon as we find out how to use equal distance 3D vectoring in a formula on the angles in the datasheets from observations, we can then get a true shape in second by second motion in the field lines. This torus field is by no means a stationary field, as the sun moves north and south during the year.
Well, that's the explanation, I think, that the sun is a personalized source projection that you can only see, and the evidence for that is when you're standing at a lake, right? You can only see the sun that goes to your foot. You cannot see the beam that goes to your friend. So I think everyone has a personal real-life example where you can confirm this is true, but no one's ever sat back and thought about the implications of such an observation, right? Like, what would that actually mean then?
Yeah, it's pretty profound when you take a second to think about the implication there. It's personalized and local to you.
Yep. Nope. So that's addressing Jeran's globe proofs or whatever. Does anyone have any other thoughts or things to add? Questions?
No, sirs.
I'm quite used to this. We've got like a full house over here, ton of people, but I'm not used to having so much talking time with so many people.
Yeah, I think as soon as we stop, they might chat up. I think.
Yeah.
Hello.
Hey, Lily.
Hey, I wanted to just make a comment, Alan, about what you said about how they want us to believe that everything came from nothing, and it's weird, of course, because the exact opposite is true, which the implication would be that the creator is, basically for all intents and purposes infinite, and he's created this beautiful enclosed finite world specially for us, So
Yeah.
it's just ironic that it's like kind of, for me, kind of the opposite,
It's funny, Lily.
Totally.
I was just thinking how they're trying to geoengineer and ruin everything. Like, thank God made a firmament and a protective thing where man couldn't fuck up the whole world for everyone else. Because they were trying to bomb it, nuke it, poison it, bring it down, put powder spray it, with just everything they can possibly do, and we're still here. So thank God for that. I was thinking about that the other day on the other side of it.
Think about the logic behind this, right? They were like, all right, we got these bombs that are so, allegedly, right? We got these bombs that are so devastating, they could destroy the world, right? They're actually so deadly, we actually can't even use them because everyone will just be like, dude, what is wrong with you people? You just killed everybody. You can't do that, right? So what are we going to do with these bombs, right? Oh, we should detonate them in the sky where we could remove the atmosphere and kill everyone for sure. They did that. And
Do you see that giant crystal structure in the sky that contains all of the universe and keeps all the unknown out? Yeah. You want to blow it up? Yeah.
You want to blow it up? Yep. Hey, shout out to the boys though. Mad respect. I'd probably blow it up too. We've all played Minecraft with admin mode on and just went around with TNT and restructured the seed.
Also, I put in chat my conceptualization of that toroidal sun model we just saw with the toroid over the Earth. I put some Canva art, some concept art, I guess we can call it.
Nice little fan art. Very cool. All right, I'm gonna close this out. Thanks for tuning in. Check us out on Sunday on Glowbusters.
And drink coffee.
Welcome to the show where you don't know if it's part of the show. Welcome to the show. If you don't know, it's part of the show. Didn't they teach you to reach for the stars while opening up the bars and keeping you chained down with mortgage bills and cars? Vaccines for your arms, kids sounding like supercharged, caffeinated hate-filled scars and rage-quit repertoires. No answers for yards, caught up in emotion that's not even yours. Imposter truths like impeccable retards, lined up for your serving of Gish Galloping wars. No remedy can't save the lost, in love with the yarn. I'm tired of walking into refracted shards, poor science displayed by disgusting bards. Soaked in sin with your dupe is delight and a new hand of cards. Been so long, seems like for love I'm just too hard, that's it. Welcome to the show where you don't know if it's part of the show.